What if the most powerful telescope wasn't orbiting above us in space, but sitting right here on Earth? For years, we've looked to Hubble and the James Webb Space Telescope as the crown jewels of astronomy. They gave us those breathtaking images of galaxies, nebulae, and stars that seem too beautiful to be real. But in 2025, something extraordinary happened. A brand new observatory, hidden high in the Chilean mountains, captured its first images. And they're not just beautiful. They're unlike anything we've ever seen before. This is the story of the Vera C. Rubin Observatory, a ground-based telescope so powerful it's set to change everything we know about the universe. The Rubin Observatory released its very first images in June 2025, and the world of astronomy hasn't stopped buzzing since. Why? Because each photo contains more information than you can wrap your head around. Imagine a single image with 3.2 billion pixels. That's so detailed it would take 385 separate 4K televisions lined up side by side just to display one snapshot. And that's only scratching the surface. This telescope doesn't just take pretty pictures. It generates an avalanche of data. Every single night, it can collect around 20 terabytes of information. That's more than most people will ever use in a lifetime, stored in a single evening of cosmic observation. But here's the kicker. Those images aren't sitting in Chile, where the observatory is perched. They're beamed across a dedicated 100 gigabit connection all the way to Miami, Florida, before spreading to research centers across the US and beyond. It's a direct cosmic pipeline from the Atacama Desert straight into the hands of scientists around the world. And the images themselves? They're more than beautiful. They're a preview of the universe as we've never seen it. But the real story of why this observatory matters runs much deeper. At first glance, you might wonder, if we already have space telescopes like Hubble and Webb, why do we need another one down here on Earth, where the atmosphere gets in the way? Here's the surprising truth. The Rubin Observatory isn't competing with Webb. It's doing something completely different. Webb zooms in deep, focusing on tiny slices of the cosmos in incredible detail. Rubin, on the other hand, is about scale. Instead of peering into one small patch of sky, it can scan enormous swaths of the heavens in record time, giving us a wide-angle view of the universe that no space telescope can match. And location matters. The observatory sits high on Cerro Pachon, a mountain in Chile's Atacama Desert. This is one of the darkest, driest places on Earth, far from light pollution, and with some of the clearest skies known to science. That's why so many of the world's greatest telescopes, Gemini South, the Giant Magellan Telescope, and the European Extremely Large Telescope, are clustered in the same region. But there's one more reason Rubin matters. This observatory isn't just a piece of hardware. It carries a legacy. The name behind it is as groundbreaking as the science it will unlock. Back in the 1960s, astronomy was a man's world. Women were rarely seen in the field, and when they were, they often went ignored. But Dr. Vera Rubin refused to stay silent. She devoted her career to studying how galaxies rotate, and what she found shook the foundations of modern science. Her measurements didn't match the predictions of physics. Stars at the edges of galaxies were moving far too fast to be explained by visible matter alone. Something unseen had to be exerting a gravitational pull. That something became the first compelling evidence for dark matter, an invisible substance that makes up most of the universe. And Rubin discovered this while balancing her career with motherhood, a nearly impossible challenge at the time. She pushed through prejudice, skepticism, and dismissal, and her persistence changed astronomy forever. It's no accident that the most ambitious observatory of our time bears her name. Just like Vera Rubin, this telescope is rewriting the rules and opening doors to mysteries we can't yet explain. But the legacy doesn't end with the name. The technology inside the Rubin Observatory is just as revolutionary as the woman it honors. Step inside the Rubin Observatory, and you'll find the Simone Survey Telescope, an engineering marvel unlike any other. At first glance, it looks like a standard reflecting telescope, but the design is far from ordinary. Most telescopes rely on two mirrors to focus light. Rubin uses three. This triple mirror system corrects distortions better than its predecessors, giving it one of the sharpest, clearest wide-field views ever achieved from Earth. And attached to this telescope is something just as extraordinary, the largest digital camera ever built. Imagine a camera the size of a small car, weighing nearly 3 tons, and capable of capturing ultraviolet, visible, and near-infrared light all at once. That's the Rubin camera. Its specifications border on science fiction. At over 3 meters long, with 189 sensors stitched together into a massive mosaic, it can snap exposures that span 10 square degrees of the sky. To put that into perspective, one picture covers an area equal to about 45 full moons. Every single shot is like a treasure chest, overflowing with stars, galaxies, and phenomena we've never cataloged before. And this isn't just a camera, it's a time machine, because its real power lies in how it will capture the entire sky, not just once, but over and over again, night after night, for an entire decade. That's where the Legacy Survey of Space and Time, or LSST, comes in. Think of it as the biggest cosmic movie project ever attempted. Over 10 years, Rubin will photograph the entire southern sky every 3 nights. That means, by the time most of us have finished a long weekend, Rubin will have built another sweeping map of half the universe we can see from Earth. To understand how groundbreaking this is, compare it with one of the most important projects in astronomy, the Sloan Digital Sky Survey. Sloan took 20 years to map just 35% of the sky. Rubin will cover 50% in 3 days. Then it will do it again. And again, for 10 straight years. This isn't about a single snapshot. It's about motion, change, and evolution. By layering each new scan over the last, astronomers will create a searchable time-lapse of the cosmos. It will be like watching the universe breathe. Stars flickering, galaxies colliding, supernovae exploding, and comets racing across the night. But the LSST isn't just about the big picture. It has 4 specific goals, each of them bold enough to make headlines on their own. First, Rubin will go after one of the biggest mysteries in physics: dark matter and dark energy. These two invisible forces make up about 95% of the universe, yet we barely understand them. By mapping billions of galaxies and measuring how their light bends and stretches, Rubin will give scientists the clearest picture yet of how dark matter clumps together and how dark energy is driving the universe to expand faster and faster. Second, the observatory will catalog objects in our own solar system. Millions of asteroids, comets, and other small bodies are waiting to be discovered. Some of them could one day cross Earth's path. Rubin may become the world's best planetary defense system, spotting potential threats long before they get too close. Third, it will monitor transient events, those fleeting moments in space that happen without warning. Supernovae exploding into brilliance, gamma ray bursts lighting up the sky, stars pulsing in strange rhythms. Until now, many of these events went unnoticed. Rubin's constant watch means fewer cosmic surprises. And fourth, it will map our Milky Way in exquisite detail. By tracking the positions and motions of billions of stars, Rubin will help us understand how our galaxy formed, where it's headed, and maybe even where life has the best chance to take hold. That's a lot for one observatory, but remarkably, the Rubin team doesn't expect us to wait 10 years for results. In fact, they've already started sharing what the telescope can do. Even before the observatory was fully operational, The Rubin team gave us a glimpse of its power. After just 10 hours of test observations, it captured images that left astronomers stunned. One of the first mosaics, nicknamed the Cosmic Treasure Chest, covered a 25 square degree patch of sky in the Virgo cluster, about 55 million light years away. At first glance, it's a sea of glittering lights. But look closer, and you realize those aren't stars. They're galaxies. Over 10 million of them, crammed into a single frame. That's only 0.05% of the 20 billion galaxies Rubin is expected to document over the next decade. And this was during testing. Another image zeroed in on the Lagoon Nebula, a glowing pink cloud of gas and dust where stars are being born right now. Normally faint and hard to spot, Rubin's long exposures revealed it in dazzling clarity. When combined into mosaics made of hundreds of individual exposures, the details came alive. Ribbons of gas, clusters of baby stars, and dark tendrils stretching through the void. These aren't just pretty pictures. They're proof that Rubin can deliver exactly what it promised. Data-rich images that expand our understanding of the universe with every shot. And remember, this is only the beginning. 10 years from now, the archive of images will be so vast that even the world's best supercomputers will struggle to keep up. So what does all of this mean? It means we're building the most detailed movie of the cosmos ever attempted. For the first time, humanity won't just see the universe as a collection of still images. We'll see it as a living, dynamic system, changing, shifting, and surprising us at every turn. Somewhere in that mountain of data could be the key to solving dark energy, or the warning of an asteroid headed our way, or the first glimpse of something so unexpected that it rewrites the textbooks overnight. The Vera Rubin Observatory isn't just another telescope. It's a time machine, a defense system, a cartographer, and a detective all in one. It's a tribute to a woman who dared to challenge the scientific establishment, and a window into mysteries we haven't even imagined yet. The universe is about to open up like never before. The only question left is, are we ready for what it reveals?